Dear students, let's study a very important concept of time-varying magnetic field, also abbreviated as TVMF. Say we are given with a magnetic induction in which a circular coil of enclosed area A is placed. So we can say that at any instant a specified magnetic flux is passing through the coil. Now say if this magnetic field starts increasing with the time, for which we are talking about time varying magnetic field, we can say if B changes with time, and we can say at any instant magnetic flux passing through the coil also changes with time, and if magnetic flux starts changing with time, we can say it induces an EMF in coil. Now in this situation we can see at any instant, say if this coil is having n turns, we can directly find out the flux linked with the coil. With the coil means I am talking about the total flux linked with all the turns of coil. We can write it as BAN, as the flux passing through the coil is BAN, as there are n turns, the total flux linked will be BAN. And in this situation we can directly write the EMF induced in this loop, which is termed as loop EMF, which is written as mod of d phi by dt by Faraday's law. So in this situation, area and number of turns are constant, so we can write it as A dV by dt multiplied by the total number of turns. And this is the total EMF in the loop, so this is written as the distributed EMF in loop. This is not at any 2 points, or we can say that there is a potential difference across any 2 points of the loop. Here it is distributed. And the direction of this loop EMF can be obtained by Lane's law, as here if we consider B is increasing with time in inward direction, then a current is induced in the coil in such a way that it will oppose the inward increment in magnetic induction. So current will be induced in anti-clockwise manner, so that this current will develop a magnetic induction in outward direction so as to oppose the inward increment. So this is the direction in which the loop current will be induced, and to induce such a current, if we talk about this EMF, it will be distributed at every segment of the wire, or we can consider there are small batteries which are induced, or small EMFs which are induced throughout the loop in such a way that if several such EMFs are induced, all will cumulatively produce a current in anti-clockwise manner in this loop. So in this situation we can say if coil resistance is R, induced current can be directly given as I is equals to the summation of all these EMFs, which is the loop EMF divided by the total resistance of coil, which can be written as AN by R multiplied by dV by dt. So you must be careful whenever we are required to find the EMF induced in a closed loop placed in a time varying magnetic field. It can be given by area multiplied by dV by dt, and if there are some terms we can multiply. And you can also just keep this note that the direction of induced EMF or induced current in time varying magnetic field is given by, this can be directly obtained by Lane's law, as the current is induced in such a way so as to oppose the increment or decrement in the external field due to which the current or EMF is induced.